Okay, so we're going through question number 15 here on Activity 2 from Unit 2. And we just have an enthalpy question here. And I'm just picking up Part C. You can see the balanced chemical equation is given as 1 mole of barium plus 2 moles of water yields 1 mole of barium hydroxide plus 1 mole of hydrogen gas, as well as 660.2 kilojoules of energy, or heat. So 660.2 kilojoules per mole of barium is released. So in Part C, actually before we get there, just looking at the stoichiometry, since we know it's a 1 to 2 mole ratio, if 660.2 kilojoules per mole of barium is released, and we have 2 moles of water for every mole of barium, then we can take that 660.2 kilojoules and divide it by 2 moles to get 330.1 kilojoules per mole of water. So this is the amount of heat released with only 1 mole of water, which makes sense, since if we only had 1 mole of water, we would have half a mole of barium, and therefore half the energy is released. Okay, so question C is then asking, what if you had 3.65 grams of water to react? Well, we know that 3.65 grams of water times the mole ratio of 1 mole of water over 18 grams of water, which is the molar mass. So 3.65 divided by 18 gives us 0.203 moles of water. So 3.65 grams of water translates to 0.203 moles of water. Well, we know that 330.1 kilojoules is released for every mole of water. So here we have 0.203 moles of water. So if we multiply those together, 0.203 moles of water times the 330.1 kilojoules per mole of water, moles of water cancels, and we're left with 67 kilojoules of energy is released. So for this question then, if 3.65 grams of water reacts with barium, 67 kilojoules of heat will be released. Okay, so that's Part C. For Part D, it's really just the same question, just coming at it from a different angle. You may or may not remember that Q is just the number of moles times the enthalpy. And the 586 kilojoules of heat is produced. This is what's given in the question. And we want to know how many grams of barium would release 586 kilojoules of heat produced. Well, we know that from the above question, 660.2 kilojoules of heat is released for every mole of barium. So all we're doing here is we're just substituting in the amount of energy released for whatever amount of barium that is, divided by 660.2 kilojoules for every mole of barium. Kilojoules are going to cancel. Sorry, I should show that. Kilojoules are going to cancel, and we're left with 0.888 moles of barium. So that's how much barium reacted to release that amount of heat. And of course, to change moles to grams is just using the molar mass again. 137.3 grams of barium for every mole of barium, so that's the molar mass. Gives you 121.9 grams of barium. So that's the amount of barium that reacted to produce 586 kilojoules of heat.